Good afternoon and welcome everyone. We are delighted to be joined today by Nathanel Apter of UASolutions and our own CEO, Annelies Scalieres. We are today going to be looking at SORA 2.5, a practical case from Switzerland to understand how it works. Nathanel has been part of the JARUS task force behind EASA's SORA 2.5, and he has also further been advising operators on how to get approvals from the Swiss Federal Office of Civil Aviation using SORA. So he is ideally placed to be able to present on this topic. I know that Annelies wants to have a quick word first before we continue, so I'm going to hand over to her and then to Nathanel.
Thank you, Elena, and thank you very much, Nathanel, for sharing your feedback with us. I wanted to have a quick word just to mention that this webinar is organized in the context of ARPAS-UK Regulation Special Interest Group, because the UK CAA has announced the intent of developing a UK version of SORA 2.5, and that UK version would be released for consultation, possibly pretty soon within the industry, so that the UK as a whole would adopt its version of the safety methodology. So it is not done yet, but it is very highly likely that it's going to happen. And therefore, it is very useful for us to understand the JARUS official version of 2.5, so that we are in a position to understand the consultation on the UK version when it comes. I'd like also to make a comment, which is that SORA as a whole will be probably applicable more for OSC applications and not for the existing predefined risk assessment that exists in the UK, which is PDRA01. So having said all that, Nathanel, thank you again very much for sharing your feedback, and the floor is yours.
Thank you, Annelies, and thank you, Elena. So I will start by sharing my screen. All right.
That's looking great, by the way.
Perfect. Yes. So before I start, maybe as a short introduction, as Elena was saying, so our company UASolutions is helping out operators to fly legally in Switzerland, but also elsewhere in Europe, where the legal framework, so the EU regulation on drones applies, and we help on those topics specifically, so the SORA and other regulatory aspects. Maybe about myself. So I've been working for the Federal Office of Civil Aviation for 3 years here in Switzerland, where I was in charge of such applications like the one of Nathanel, but also other companies which were successfully doing complex operations. So these were the very first cases we had with SORA 2.0, and I've been following the evolution of the methodology since then, up to the point where we are now. All right. Before we dive into a practical case, I think it's important to also have a common understanding of what we are talking about. So I don't know what is the level in the audience of knowledge around the regulation in Europe. I guess the regulation in the UK might be similar, but at least for the practical case we are going to study, it's the European framework which is going to apply. So overall, the European framework applies, and it's important to have a sort of a common understanding of how the regulation is built. So I'm going shortly to describe how this regulation applies in Europe. So we have 3 subcategories: the open, the specific, and the certified category. Maybe some of you have already heard about those. The open category usually covers all the, I would say, toys use cases. So it's small drones up to 25 kilograms, always at safe distances from people, in visual line of sight, the simple use case. It's not going to interest us so much today, but it's important to understand that the simple use case can just easily be covered by this open category, where there is low to little requirements for operators. There is nowadays certain norms which apply in the open category, so the manufacturer needs to build according to certain norms. But in general, this is more the toys use case, which we are not going to look too much into today. What's going to be interesting for us is this specific category that we see here in the middle, where operators need to obtain an operational authorization from the authorities based on a risk assessment. And this is what applies in the EU, but as Annelies was saying, it might apply as well in certain cases in the UK in the future. Then there is, for the very complex use cases, so transport of people, transport of dangerous goods, there is the so-called certified category, which really covers the most complex use cases. So that would be the context, I would say, in EASA member states, so everywhere in France, Germany, Switzerland, and other EU countries. More specifically about Switzerland, so Switzerland has a bit of special legal situation because the EU law came in a little bit later than in other EU countries. We had it first in 2023, so from last year. And the previous legislation we had was very simple and very liberal. It was possible to do more or less what we wanted with drones lighter than 30 kilograms in visual line of sight. And based on this, a lot of businesses thrived and were able to generate revenues, meaning that the Swiss FOCA, so the Federal Office of Civil Aviation, wanted also to keep these businesses alive. And so they did a lot of efforts in 2023 so that companies that are willing to perform those missions could continue to do so, even if the missions would be more challenging from a regulatory standpoint. And so in general, we say in Europe that the Swiss FOCA has a rather liberal interpretation of the SORA methodology. And it's also one of the authorities which have more documented guidance on different topics when it comes to the SORA methodology. Which is why it's a good, I would say it's a good point to start to study a use case, because it's also where the use case can be most documented and most understood from a regulatory standpoint. Yeah, so that's a bit about the context in Europe and more specifically in Switzerland. I think that would be important to be first understood. I can answer more questions about those topics maybe later on as well. Then it's important, before we dive into the SORA, to have certain concepts a bit better explained. One of those concepts is the concept of sail. I don't know how many are familiar with the concept of sail. So the abbreviation SAIL stands for Specific Assurance and Integrity Level. So it may sound like some strange, complex technical language, but don't get confused. It's an easy value between 1 and 6 that basically quantifies the requirements that will need to be fulfilled for the operation. The higher the SAIL, the higher the requirements to the operation. And this value will also increase depending on the risk. So the more risks we have, the higher the requirements are going to be. Technical requirements, but also operational ones. So typically pilot license, but also maintenance, but also procedures are going to start to become more important with increasing SAIL. I think the term SORA, most of you might be already familiar with it. So it stands for Specific Operations Risk Assessment. So that's the commonly used abbreviation that we will use now in the next few slides. Also, to make it a bit clearer what SAIL represents and how to imagine it. So if we link it to the ground risk, and we will see that in the coming slides. So the higher the population density on the ground, the higher the sale will be. We see here an example. It's purely indicative because it also depends on the size of the drone. It depends on a lot of things that we will see a bit later. But we see here as an indicative value, more or less the sale increasing depending on the population density on the ground. Meaning sale 1, we have no one, there is no risks. And sale 4 would typically be flying in the city center of a larger town. Yeah, exactly. Then we have another value, which is also important. So another definition, I would say, which is important to understand for the next steps. It's the concept of robustness level. Maybe also some of you might have heard that before or understood that before. This term is very often also a bit complex to understand. It's often described by two values, what we call the level of integrity and the level of assurance. The level of integrity is how good an objective is at reducing the risk. And the level of assurance is the degree of certainty that we will have to show that this risk reduction is actually happening. So typically, the level of assurance can be a declaration, but it can also be having a design verification. It depends a little bit how high the sale will be and how high the risk will be in general. Usually, this robustness level is either low, medium, or high. And we will see that this level is thoroughly documented in certain annexes of the SORA. We will not dive too much into that because I guess that's more boring part, I would say. But overall, it's maybe important to keep this in mind also for the documentation of the paperwork. And we will have a short look at it also in practice to better understand what that means. So low, medium, and high, that's the type of robustness level that we can have, and they basically drive the requirements that we will have to fulfill. Yeah. I'm taking the questions at the end. I imagine maybe if there is already some questions, I think, Elena, you said we can add those in the Q&A whenever the questions are popping up.
That's right. We will take questions at the end.
Perfect. All right. Then the SORA, so we would then dive into the SORA process. What's the SORA process about? So usually the SORA process, and this was already the case in the SORA 2.0, but it's becoming increasingly clear with the SORA 2.5, is actually two parts. SORA stands for Specific Operations Risk Assessment, but it's not just a risk assessment, it's also demonstrating compliance with certain requirements that are stemming from this risk assessment. So we will have a first phase where we will analyze the risks on the ground, the risks in the air, and then we will derive this sale value between 1 and 6. And based on the sale value, we will then comply with the requirements stemming from this sale value. So it's two phases, and we will deal with each phase independently. So, and it's important usually to get an agreement from the authority on the sale first before moving to the next step, which is about compliance. Since if there is disagreement on the sale with the authority, this will affect the entire assessment and the entire compliance work. So if we go to phase 1, which is the risk assessment part and the requirement derivation part. So we have basically several parts in this phase 1. The SORA is split in 10 steps, and most steps actually belong to phase 1. So first, we will have to describe the operation. That's the step 1, detailed operational information. So basically describing what we intend to do and identifying whether it's in the specific category, right? Because if it's in the open category, maybe we don't have to go through the SORA. Then we will use, based on this information and based on where we want to fly, we will make an analysis of the ground risk. That would be the step 2 that we see here on the left. We can then mitigate this ground risk, so reduce the ground risk with certain methods that we will see as well. That would be the step 3. In parallel, we have the air risk that we will have a look at, so we will basically establish the initial air risk class. That's the step 4. We have also the opportunity to reduce this air risk. Then we will have also in step 6 to address the residual collision risk, I would say. So what is left of risk to have a collision with other aircraft is usually addressed in step 6. And based on the air risk class and the ground risk class, we will determine the sail that we have seen before between 1 and 6. Additionally, and that used to be forgotten a lot in the previous SORA version, the SORA 2.0, there is also the risk of flyaway that is a bit looked at separately in the SORA. So the risk that the drone starts going into a direction and exits the area where we intended to fly initially. And that's what we call the containment requirement, and it's addressed in the step 8. And following the step 8, we have the step 9, which is about compliance. We will see it could already belong into phase 2 because it's about demonstrating that we comply with the sail and with the objectives that the sail established. Yeah. The next step would be to have a look at a concrete use case because it's all very abstract, and I hope I didn't lose everyone already on those concepts. And I think the best is to really look at a concrete use case in order to really understand how this applies in practice. Before I go into a concrete use case, maybe it's important to say the following. First of all, SORA 2.5 is not yet applied in the European Union, and therefore the example that we will study was authorized or similarly authorized on SORA 2.0, but it was not yet authorized on SORA 2.5. It's a fictional operation, but it's very similar to an operation which has been authorized in Switzerland. We note also that the SORA process, and that may seem a little bit overwhelming for some of you, it's a longer process to show the airworthiness of an operation. But in general, it's not because we have a look at this specific use case that it's only valid for a specific place. In general, a SORA can be valid for a set of missions for an entire country, for the entire United Kingdom, or for the entire Switzerland. But it is by no means specific to a location. We will study a location today in order to have something more visual, I would say. But it's not the idea to have something specific to a location. And then, yeah, something which is worth saying as well is the implementation of the SORA really varies from one country to another. So I cannot foresee exactly how it will be implemented in the UK, but I know how it applies in Switzerland, and some things might be similar, some things might also be different. All right, so to the use case. So we will study a use case. Some of you are maybe familiar with this drone already. So it's a use case of the DJI Matrix 350, which is a drone used a lot for photogrammetry flights, and that's exactly what we will study today. So the idea is, fictionally speaking, is that the city of Geneva would like to establish a digital terrain model. So the operation will take place in Geneva, and it's a kind of proof of concept that we have here in this neighborhood, Champel, where the drone is going to establish a digital terrain model of this neighborhood. Before we start, so we have to check that that it's not an open category use case, and there is no standard scenario which would cover this use case as well. Otherwise, these would be other categories that would be used, but it wouldn't be necessary to do a SORA evaluation. We also will check that there is no-go from the authority. So if the authority says that's not possible to fly here because there is a very critical infrastructure or anything else, then it wouldn't be worth to actually go through the SORA process. So here it's not possible to fly in the open category because obviously we are going to overfly people. It's not in a city center, but it's quite a populated neighborhood of Geneva. So it's not really doable to fly in the open. So we will automatically use the SORA. There is also no standard scenario covering that kind of use case. All right. Then we can start with the first step. So usually the first step is really like looking at the place where we are going to fly, maybe establishing also where we will take off. So here we have a roof on the building number 1 of Rue Albergo in Geneva, which will serve as a takeoff and landing location and also the place where the pilot is going to be located. In step 1, it's also a good opportunity to understand if we are in visual line of sight. So to establish whether we are in visual line of sight, here we can follow the Swiss FOCA guidance. And the FOCA guidance basically gives us a formula to calculate the visual line of sight distance. Here it's 490 meters. So clearly the operation is not in visual line of sight. Therefore, it's for us a bit challenging. We could treat this mission in beyond visual line of sight. For our use case, what I will do is we will keep it a bit simple, and especially because the time today is limited. So what we are going to do is we will place a second pilot, a co-pilot, in here, so that we are able to keep the drone in visual line of sight for the entire flight. Meaning there will be a kind of handover of command and control. This is something that exists with the Matrix 350. The remote control is able to hand over the control from one remote to another. And so we will be able to consider the entire operation in visual line of sight. Handover is usually a trick that we can use to extend the visual line of sight distance without going into beyond visual line of sight use case. And so that's about the visual line of sight distance. Then something that we need to do also in the first step is to study a little bit more the area and especially the safety distances. Those safety distances are important for our ground risk class evaluation. So in general, here again, I don't know what's the level of knowledge around the audience, but we usually introduce safety margins around the area where we intend to fly. So the area where we intend to fly, which we see in green, is commonly called the flight geography. Around this flight geography, we define what we call a contingency volume, which we see here in yellow. And this contingency volume is here for all abnormal cases, meaning problems with command and control, problems with navigation accuracy, problems that could occur during normal operation. Here again, so the Swiss FOCA provides a guidance on how to calculate it based on different things, among other, the accuracy of the navigation, the position hold error, and also the reaction time of the pilot, and the distance for the contingency maneuver. In our case, it would be about 30 meters. So that's important to calculate this distance, which we see here, like I said, in yellow or orange. Then we have as well the ground risk buffer. This is this huge area on the ground in red, which is usually calculated as equivalent to the maximum operating altitude. So the maximum operating altitude, if you recall, was 120 meters, right? And we add as well a margin vertically to this maximum operating altitude, which is around 30 meters, again, of contingency volume, because this also exists vertically. So basically, the ground risk buffer in our case would be 150 meters in total, which corresponds to the maximum operating altitude. Those three areas together are called the EGRC footprint, the intrinsic ground risk class footprint, because that's the place where we are going to determine our ground risk. Exactly. So based on that, we go to the second step. So the second step is basically based on this area, we can now look what kind of population density do we have in those in this EGRC footprint, and determine the maximum population density. We can also, based on the characteristics of the drone, determine the maximum speed of the drone and the maximum dimensions of the drone. And we will get a ground risk score, which is here 7. So that's due to the fact that we have a quite high population density, 6,331 people. But also the drone is classed in the second column of this table because it exceeds 1 meter. The velocities could be in the first column, but the size of the drone is clearly in the second. So we see we have a ground risk class of 7. This is already quite high. So we will find this out later on in the SORA. Usually, in step 7, we determine the sail based on this ground risk class. Here I'm fast forwarding a little bit so that we can really also understand what that means in practice. But in step 7, we have this table that allows us to determine the sail based on the ground risk class. And we see that with a ground risk class 7, we have a sail which is a sail 6. So that's a very high requirements for the operation. So we need to think about strategies to reduce this sail to a lower sail. Ideally, a sail 2, maximum a sail 3. These are sails that we will be able to fulfill, but sail 6 is not realistic in our context. And here we can make use of different ways to do that. The first thing to look at is to make use of the flexibility given in this step 2 to maybe change line or change column, meaning having a lower population density or having a smaller classified drone or a smaller velocity drone. And the SORA gives us this flexibility. So we have in one of the annexes of the SORA some quantitative methods that allow us, under certain circumstances, to actually reduce the column which is used. So if we have a maximum velocity which is reduced by 25%, then we can increase the maximum size by 70%. And that would allow us to have the matrix 350 classed in this first column of this table, because we have a speed which is 25% lower than 25 meters per second, but we have a size which is 70% or 40% actually larger than 1 meter. There would be other ways, so the other trade-offs could apply as well now. We are far away from the maximum population density of 50,000 people, so we could have used as well the first trade-off. Exactly. So this way we are able to reduce already the ground risk class to a ground risk class 6. And that means in practice that we will be with a maximum sail of 5, which is still far too high. So then we need to think about more strategies to reduce the ground risk. And that would lead us to step 3. So in the step 3, we have the possibility to reduce the ground risk using what we call mitigations. So basically there is 4 types of mitigations with this new SORA, and I think that's one of the largest difference with the SORA 2.0. So we have sheltering meaning that we usually consider that people spend most of their time inside, and this is a valid assumption for, I would say, for residential area at least. For other places it can be also argued. We can use in this context this mitigation, so we can get a -1 point reduction out of that. Then we have the M1B mitigation, which is about operational restrictions. This would typically apply if we fly at night, or if we fly in certain context where the population density on the ground is lower than what we evaluated in the beginning. Here, it's not really applicable for our context, so we will not make use of it. Then we have the mitigation M1C. That's about being able to observe the people on the ground and to reduce the risk by maybe changing flight path during flight or adapting our flight path to the population on the ground. Typically, if we are in visual line of sight, we are able to use this mitigation. So in our case, that would be also the case. And then, so M1A, M1B, M1C are mitigations which are usually aiming at reducing the amount of exposed people on the ground. Then we have M2, which is another type of mitigation, which is more about reducing the effects of a crash or the effects of a ground impact. This is typically the parachute mitigation, or a frangible design would also fall into M2. So here we are going to make use of a parachute because we see that otherwise we are not able to get those 3 points reduction. Yeah. Maybe also on these mitigations, so it's not just sufficient to just say, well, I'm using that, or I'm using that, or I'm using that. We need to show that we are fulfilling the requirements behind those mitigations. I brought an example here. So if we take M2, so the parachute, there is in the Annex B of the SORA several criteria to fulfill. For example, that the impact dynamics and the impact hazards are reduced to an order of magnitude of 90%. So usually there is several criteria to fulfill for each mitigation. I will not go too much into the details here. I think in general, to fulfill something like that, it looks a bit overwhelming, but at least the EASA in Europe provided certain kinds of standards or means of compliance, which can be just used by the manufacturer or by the applicant to show that they fulfill these criteria. And probably a similar line of thought will be established also in the United Kingdom when it comes to mitigations or to fulfilling standards. All right. Following this, also important is to take the impact of the parachute into account for the size of the ground risk buffer. So this ground risk buffer in red are here to account for the potential crash of the drone. Therefore, if we use a parachute, there might be some drift of the drone whenever the drone is actually being terminated and coming to the ground. There might be some drift due to the wind. And it's important to account those wind effects as well in the size of the ground risk buffer. So it might be that the aviation authority does not accept the 1-1 rule anymore, but that one needs to calculate a little bit more the exact size of this ground risk buffer. So we see we are in step 3, and it's quite overwhelming. It's quite some work behind all those laws. So let's take a deep breath before we go to the next step. I would, however, say now we did the most, I would say the most heavy part. The rest will fall probably a little bit easier, at least when it comes to the air risk. The work is slightly simpler. So the air risk is the step 4 of the SORA. For that, we have an easy workflow. So basically, we can just follow this diagram and identify in which airspace we are flying. And this will tell us what's the air risk class. And here we are in urban area. We are in uncontrolled airspace below a certain altitude. So we have an air risk class C. Here again, we have the possibility to reduce the air risk class. So usually there is a lot of arguments to reduce the air risk class. Here, for instance, we can use the fact that we are in visual line of sight again to say that we see incoming traffic, and that would be an applicable strategic mitigation, so reduction of the risk in the airspace. Another one would be to consider the rules applicable for manned aircraft. So typically, manned aviation has a minimum flight altitude of 300 meters in urban area. So usually below 300 meters, there is not supposed to be much traffic, I would say. And that could be also considered a kind of mitigation. Based on that, we can reduce to our air risk class to air risk class B instead of air risk class C. Also step 6, which is often forgotten and which is especially important for beyond visual line of sight use case. So the step 6 basically tackles the residual collision risk. That's what I mentioned before. So one needs to be able to demonstrate that one can also go out of the way whenever a manned aircraft is actually incoming and closing to our operation. So it's about having procedures on what to do in case of an incoming manned aircraft. Then we go to step 7. So I mentioned it already before. This is the sail determination step. So in the sail determination step, we will have ground risk 3 and air risk B. And this leads to a sail 2. And yeah, here maybe some people might wonder as well, well, we did everything to actually have a sail 2, right? We could have had a sail 3 or a sail 4, since could also have chosen not to use a mitigation or another. And I would say that depends very strongly also on the drone you are using, since some drones do comply with SAIL 3 and some others do not. Currently, at least, there is not that many drones that have a design verification for SAIL 3 or that have been approved for SAIL 3 operations, but there is a few. It's not the case of the Matrix 350. So because of the fact that it's not yet compliant with SAIL 3 norms, our best guess is probably to go with SAIL 2 and to do everything possible to actually stick to a SAIL 2 use case. Maybe in the future, DJI will do the SAIL 3 compliance activities and show that they are SAIL 3 compliant. But in SAIL 1 and 2, there is not much technical norms and technical standards needed, while in SAIL 3, 4, 5, and 6, it's typically the case. Following that, we have the step 8. So step 8 is a bit the complete new thing for most people when it comes to the SORA. It was not something present previously. So basically, and that's quite important, and I will make it short from here because I see also that time is running. Yeah, so step 8 basically is about determining the containment requirements, this risk of flyaway that I mentioned in the beginning. So for that aim, we usually calculate 3 minutes of flyaway at full speed. And here we get 3 kilometers. And what the SORA says is basically if we have a value below 5 kilometers, we should use 5 kilometers as adjacent areas. And then we do a kind of averaging of the population density in those areas, which gives us here 4,646 people per square kilometers. And based on this average and the SAIL we had, we can establish the so-called containment requirements, which are here low. Yeah, this again will drive some requirements in the SORA that we will need to fulfill with regard to flyaways. Those requirements are usually identified in the step 9. So here we see again a bit an awful table. So with these low, medium, and high levels that I mentioned before, and depending on the SAIL, a low, medium, or high level for those objectives established in the SORA. We can have a look shortly what that means in practice for one of those operational safety objectives, which are at the end of the SORA in the compliance phase. So that's already phase 2, where we actually comply with the requirements. And we see that, for instance, OSO 3, so the operational safety objective 3, is about maintenance. It's about having instructions for the maintenance of the drone, which cover the designer instructions. It's about having maintenance staff which is competent. It's about having maintenance instructions which are documented, having a log system available to log maintenance, having also a system to record the qualification and the experience of the maintenance staff. And here again, we use this kind of compliance matrix to actually show the compliance to those requirements. All right, I think, yeah, we would be through. So I think I would be glad to take a few questions as well, if there is any.
So before we dive into the question with Elena, Nathanel, well done, because you walked us through a user case where we started at a ground risk of 7, ARC-C, and you managed to transform it into a SAIL 2, so well done. Now, having said that, Elena, why don't you walk us through some of the questions that have been asked within the Q&A function?
Certainly. So let's start with the first one, which is SORA 2.5 includes Annex E, dedicated to cyber risks. Should the cyber risk reduction measures be addressed as part of final GRC or residual ARC or other operational risk analysis? Do you have examples of efficient and acceptable cyber risk alleviation measures?
Yeah, that's an excellent question. So basically for now, the cyber requirements were not overtaken in the acceptable means of compliance in Europe. I don't know how that will be in the UK, but it's still pending. And I think it's not so clear in which way they are going to be taken over. There is a cyber annex. However, the cyber compliance is mostly at these objectives level. So depending on which objective we are talking about, there might be certain requirements that are related to cybersecurity. For instance, if we talked about maintenance, maybe maintenance should be also, or I would say, bulletproof to cyber attacks. For instance, firmware updates or other updates which relate to maintenance should be also protected against cyber attacks. And so how this is dealt with is usually specified at OSO level. And the cyber annex within JARUS really tackles those OSOs, each and every one of them, and has a look what is required from a cyber standpoint. In SAIL 1 and 2, again, the cyber requirements would be rather low. So it's just about following good practices, having equipment secured with a password, and in safe places whenever necessary or whenever it's safety relevant.
Thank you. On BVLOS, what are your experiences with introducing ground observation tactical mitigations and them being accepted?
Yeah, so it's a good question. With BVLOS, a lot of challenge started, and that's why we didn't go through a BVLOS use case today, because it would have taken us the entire day probably. So it becomes more difficult, but everything is possible here again. This mitigation M1C becomes more difficult to implement because it's about ground observation. It's about seeing people on the ground. And if you're in BVLOS, you don't see people on the ground. So there is a lot of discussion whether we could use technical systems to do that instead of people and use M1C. It's still very much experimental. And I would say for now, at least, the SORA contains the BVLOS use case mostly outside of cities and mostly outside of urban environments, unless one goes through SAIL 3, SAIL 4, projects, and then the situation is slightly different.
What if it is not possible to visualize entirely, full-time, the overflown area? The M1C can still be assumed equals to -1?
Yeah, that's an excellent question. So it's funny because we had this discussion with the Swiss FOCA, because like I said, this example was actually approved in Switzerland. And the applicant was a bit dubitative on the possibility to actually keep also the area which is in red in visual line of sight, because that's really a lot of area to keep in visual line of sight. And especially, is it really possible to see the people on the ground that far away? Even closer, I mean, 490 meters visual line of sight distance is actually quite a bit to also be able to see the people on the ground. So basically what we established with the FOCA, but I wouldn't say it's definitive, it's the fact that the green and yellow area needs to be in visual line of sight, while the red area is the area where the drone could potentially crash, but it's not important, at least during the flight and during normal conditions, that this area gets this kind of reduction. So I would say there is still here best practices to be established on how M1C is really put in place. Like I said, the Swiss are usually quite willing to discuss and to find compromise and to make this regulation also applicable in practice. In other countries, it might be a bit different. They might not necessarily go that easily on such compromises.
Indeed. Yeah. How do you get credit for a GRC reduction for ground observers in an area so large? An FPV camera on board or actual people assisting the operation?
Yeah, that's exactly, again, it's M1C. Huh?
Mm.
So M1C, if you are able to see the people on the ground, to see what's surrounding. On the technical means, there is a lot of discussions to be still had because I don't think anyone tried it out yet, just because SORA 2.5 is not yet out. But it's totally doable to imagine a case where the surveillance would take place only with technical means. Observers for the ground that's already being used in certain applications, and yeah, it would be a M1C mitigation.
Which app has been used for the calculation of the population density in the 5 kilometers around the operation?
I knew this question would come. So I have to admit it's someone in my team that had a look at this tool, and for now we are still experimenting a little bit within UASolutions to find out. But I believe, if I'm not wrong, it's mappen.fr. It's a French tool, and it seems that it's possible using this French tool to actually get an averaging of the population density in a larger area like that. I don't take any responsibility on this tool. Like I said, it was more trial, and I'm not sure it works as intended. It's also something that we did quite quickly now for this assessment, and that we would need to, I would say, review or peer review first before we use it as an official tool. I'm also not sure that EASA or CA UK would accept that. So yeah.
Indeed, it's going to be one that's fairly key to all of this. What changes can we expect from SORA 2 to SORA 2.5?
Yeah, so the main changes are this step 8, because the previous containment was very difficult to grasp for most people. It was poorly written, and it was not clear which size of adjacent areas we had to take into account. Also, enhanced containment, which corresponds a bit to medium or high containment now, was triggered very easily and in a lot of instances, which blocked many operations since, yeah, it was something quite new. No one was really familiar with it, and there was no means of compliance initially to comply with that. Now there is systems which are compliant with enhanced containment, so with medium or high containment. And also, like I said, it has been completely reviewed here. This is a complete new method. So I would say this step 8 about the containment is brand new. And so we didn't have M1A, M1B, and M1C. So this got introduced with the SORA 2.5. There is a few other adjustments, like for instance, M3 is not a mitigation anymore. So the emergency response plan used to be considered a mitigation, and it's not. There is a few other adjustments. I would say the SORA 2.5 has a lot of guidance. It's much clearer. It's also shorter in some instances. It's more quantitative. But that has a bit the drawback also that this will create a bit more work on the side of the applicant and on the side of the authority. So that, yeah, cannot have something better without a bit of a drawback as well. So yeah.
How would you utilize time at risk into the SORA methodology?
Time at risk? Sorry, I didn't understand that.
I'm not sure, Tobias, do you want to add another question in there or add something into the chat just to clarify what you're talking about? I'll give him a moment to do that. And in the meantime, we'll go on to another question.
I think it could be referring time at risk. It could be referring to the risk in terms of overflight when you are overflying, but just a few instants or moments, if that comes into the picture in the SORA analysis.
Tobias is saying yes. So I think that's exactly what yeah.
Yeah, so it's a super interesting question, to be fair, because for the air risk and for the ground risk, the responses are completely different. So for the air risk, we can use this low exposure time or time of exposure arguments sometimes to reduce the air risk. If you do short flights, it means you have short exposure to other aircrafts, which are themselves also having a short exposure. So overall, this adds up, and you can use that as an argument to reduce your air risk. While the ground risk, I would say it's a complete different story, because we consider that even if you fly there once, there is always the probability of crash. And therefore, even if you expose an area for a very short amount of time, it is considered as being an area to be considered for your ground risk evaluation. There would be, in experimental setup, I would say, the possibility to derogate to that and to really have a look more specifically, okay, if we fly once, only 2 seconds over a highway, maybe this is a risk that the competent authority, the CAA, would find acceptable. But I would say you cannot say that you are flying just shortly over the highway, because nobody knows how many times you are going to fly over the highway, first of all, and this adds up. And therefore, the argument is a bit difficult to bring up in a ground risk framework. So yeah, I would say in the ground risk framework, it's not something that can be used to mitigate the ground risk.
In the figure 3 of SORA 2.5, graphical representation of SORA semantic model, the emergency declared to ATM, has been removed in the new version. Why has it been removed, and what will the new proposition be?
It has been removed because the air risk, and especially the adjacent air risk, was largely overestimated in the first version of the SORA. Meaning everyone thought, oh, what happens if there is a flyaway? Then there is a higher risk of collision. However, what we found out is, first of all, it's improbable that there is a flyaway, rather improbable that there is a flyaway. And even if there is a flyaway, what is the probability that when there is a flyaway, there is an airplane that has a conflicting trajectory with the drone at that specific moment? So basically, putting everything into context, it was found out that this risk is not relevant. It's just, yeah, it was overestimated in the SORA 2.0 framework. And therefore, it was removed for the SORA 2.5.
Thank you. It's a very clear explanation. I'm just going to give everyone a chance to ask some more questions. A quick reminder, this is a fantastic opportunity to ask Nathanel these questions, and we're absolutely thrilled that he's here today. If the range that can be achieved in 3 minutes is far less than 5 kilometers, assuming the drone is very slow, shall we still use 5 kilometers?
The answer is yes, because basically these 5 kilometers are, like you saw before, we are averaging the population density. So I would say if you use the smaller size of the adjacent areas, you might get a larger average depending on where you are. So it's not even so beneficial for you to have a smaller size of the area. I would say the larger the area, the better it is, because the larger averaged it will be if there is higher population density available. However, to be fair, JARUS just established as a minimum 5 kilometers. It's important to note, I don't know if this section is still in the JARUS 2.5 document, but I think assemblies of people get treated slightly differently. We need to check that again. But I think if there is assemblies of people in the direct surroundings, then the area is not 5 kilometers, but it's less. I think it's 1 but I need to check if that's actually still in the latest draft of the JARUS document, and if I'm not saying some nonsense here. Yeah.
Thank you. That's great. So going back to our previous question around the emergency declared to ATM, the questioner has come back with a further question, a follow-up, to say, so is there no need to contact with the ATM?
Yeah. So it's a very good question. Overall, what was shown in the quantitative methods of the SORA and in the context of the ALTMOC of the Swiss FOCA for containment, is that if there is a flyaway in the middle of two runways in an airport, the probability is still very small that there is a collision. It would take something like 40 years to get a collision. I don't have the exact context of the calculation, but I think the probability that there is a collision with the air traffic management is really very low. Then it always depends. It depends on the context. I think if you are directly in an air traffic control environment, then you need anyway to get clearance from the air traffic control before you can make your flight, because that's just the way it is for drone operations. They need to get clearance. They need to get a memorandum of understanding with, in most countries, at least they get to get a memorandum of understanding from the air traffic control. If you are adjacent, then yeah, there is no need to contact the ATM. This you understood it right.
That's great. Well, that seems at the moment to be the final question. I'll give everyone 30 seconds more, but given that we have actually gone over the hour mark, always a sign of a good engaged webinar, then I will say thank you in advance. I've got one more question that's just come in. I will say thank you in advance, Nathanel, for your time and very much for this presentation. It will be posted up to the ARPAS-UK website later this afternoon, and also to our YouTube channel as well. So the final question is, for maritime operations over national or international seas, is boat/ship density considered as part of overflown population density?
Yeah, so it's an excellent question. I didn't have that many cases of maritime operation, but the few we dealt with, it was a question whether there is ship traffic and how much. So actually, yes, it is considered as part of the density of overflown population density. Then again, all those people in the ship sheltered could be also the case. Then sheltering would also apply to actually reduce the population density at risk. There is also the possibility to close an area to maritime traffic. This would typically result in a control ground area, or using M1B to have a restriction, operational restriction in time and space to reduce the people at risk. Exactly.
That's great. Thank you very much indeed, Nathanel, and thank you, Annalise, as well, for joining us and for clarification around a couple of issues that we've encountered along the way. As always, as I said, this will be recorded, has been recorded, and it will be uploaded to the website later on this afternoon, and in due course will be made available on the YouTube channel too. Do remember that we have a number of other webinars covering a whole variety of topics on the ARPAS website. Please do take a look. We're always delighted to be able to help share and inform and educate the wider industry, as well as, most in particular, our members as well. Thank you very much then, Nathanel. And thank you, Annalise.
Thanks, Nathanel.
Thanks, Elena. Thanks, Annalise.